Okay, good morning, ladies and gentlemen. My name is Tumanov, and I'm a postdoc here at UC Berkeley, working with Jan Stojka in RISELab, and I'm also one of the organizers for this event. So in the next 10-15 minutes or so, I just wanted to give you a brief high-level overview of the projects you're going to see and experience firsthand over the course of the next 2 days. So let me start with a very high-level overview of our 2-day workshop. We're going to start with a theme of system support for emerging AI applications on day 1. Roy Fox is going to set the stage for the rest of the day by introducing important reinforcement learning concepts. They will be useful and necessary for a deeper understanding of hands-on labs that you're going to experience throughout the day. And after that, we'll have Ray. Ray is, as Jan mentioned, a distributed framework for emerging AI applications. I'll talk a bit more about that later in the slides. After that, we're going to have Clipper, which is a low-latency prediction serving system. Then, after a break, we're going to have a 2-hour session which involves an integration exercise where you are actually going to take a ray-trained policy, which you will train yourself, and you're going to serve it on Clipper and play a very captivating and highly useful in production and in your daily life game of Pong. And on day 2, we will switch gears to a different theme of data analytics and security. Pyron is going to kick off the day with scalable data analytics and AWS Lambdas. Ground is then going to introduce you to contextual data analytics, where it's actually important to take into consideration the context where the data is coming from, as well as the changes over time. And we're going to conclude our 2-day workshop with Wave, which is a system that enables global scale authorization for IoT without central authority. So starting with Ray, Ray is a distributed execution framework that enables very high performance, fine-grained remote task execution with dynamic dependencies. Ray was built with 3 design goals in mind. The first one was ease of use. We simply want to be able to minimize the changes that are required to parallelize your existing code. In this particular case, it says existing Python code, but Python is not fundamental. In terms of ease of use, the target was to minimize changes that would be required to parallelize it. And it should be possible to parallelize the code that you already have, that you've already been using in order to deploy your machine learning pipelines and in order to train your machine learning models. Second design goal was performance. One of the characteristics of the RL applications that Jan was just telling you about is that they can generate actually hundreds of thousands of tasks per second. That's a lot. Ray was designed to support that and to do so while achieving millisecond level task latency. So what sets Ray apart is that it simultaneously tries to achieve throughput and latency. And third is flexibility. The nature of these reinforcement learning applications is such that you actually have to combine different types of computation. You have to deal with combining neural networks, planning, search, microsimulations, all sort of intertwined and having dependencies between each other. And you'll see that as you go through the RL exercises with Ray. And so it involves heterogeneous tasks. And by heterogeneity here, because it's an overloaded term, I mean the different resources that are being required for these tasks, as well as different durations. So all of this has to be supported, and Ray strives to achieve these 3 design goals. In the course of a Ray tutorial, you'll get exposure to Ray API, which is actually very simple. You'll learn how to parallelize existing code. You'll learn how to parallelize common machine learning training pipelines, how to encapsulate mutable state with actors, and at the end of the day, you will get exposure to one of the highlights of the 0.2 release, which is the Ray Reinforcement Learning Library. So in terms of Ray status, we've just released 0.2.0, but we're actively working towards 0.2.1. The main 0.2.0 edition is a collection of RL algorithms that are tuned well to work on Ray. as well as improved object store interaction and performance. And this is where we are. Where we are going is continuing to improve fault tolerance, both for the stateless tasks and for the stateful computation, continue to improve scheduling policies, and continue to push the boundaries of performance by improving scalability, improving stability, and improving throughput and reducing the system overheads and latencies. Clipper is the second system you'll learn about today. Clipper makes it possible to decouple applications from the machine learning models consumed by those applications. So on the top here, you have a layer of applications, and on the bottom, you have an increasing number of heterogeneous machine learning models that are being used by the applications at the top. And Clipper allows, through this decoupling, allows to independently manage these two layers and even allow different groups to independently evolve the code behind each of these two layers. So these applications are actually typically interactive in nature, and one of the Clipper's features is its latency SLO awareness. And as the applications submit queries to Clipper, it load balances across a set of suitable models in an SLO-aware fashion. So the Clipper tutorial is going to walk you through some basic exercises that show how to interact with Clipper, how to deploy models, how to send queries to those models. So by the end of the tutorial, you'll know how to deploy both library and user-defined machine learning models that you yourself will create. More generally, you'll develop a conceptual model of how Clipper works and be able to use Clipper as a tool to hopefully power your own machine learning applications even after today or tomorrow. In terms of Clipper status, the release for 0.2.0 is actually coming out very soon. The focus of that release is going to be a single command deployment in production environments, support for a number of different kinds of frameworks in different languages, including Python, Java, and R, as well as support for Kubernetes for production environments. And the roadmap is, again, pushing the boundaries of system performance and debuggability. We are highly anticipating a 5x performance improvement on serving latency, as well as model debuggability before and after deployment is going to be one of the focal points for going forward for Clipper. The day 2 is going to be kicked off by Pyran. Recall that day 2 shifts gears towards data analytics and security. Pyran is a transparent distributed execution engine on top of AWS Lambda, which simplifies many scale-out use cases for data sciences and computational imaging. Pyran enables essentially serialization of functions and data on the local machine on the left-hand side and deploying them to the cloud as Lambda functions on the right-hand side of the slide. Through the Pyran hands-on tutorial, what you will learn is how easy it is to roll out machine learning pipelines. This is going to be a good way to actually become familiar with Pyran API, which also, much like Ray, by design, tries to keep its API fairly simple and straightforward. More advanced exercises for Pyran will introduce you to using large matrix computations with Pyran, as well as hyperparameter optimization. So Pyran is now at version 0.3. And its latest release is focused on the bottlenecks of serialization and scaling. And going forward, the project targets large-scale matrix computation with Lambda Pack, support for GPUs in standalone mode, as well as increased performance and basically robustness for the whole system. After Pyran, we will have Ground. Ground is an open-source data context service. It enables the management of all the peripheral information that informs the use of data. So data context actually includes traditional application metadata, such as file system metadata or relational schemas and so forth, but it also includes behavioral context, and data context, in addition to these two things, captures how these components change over time. And this is what Ground enables. The tutorial for Ground is really aimed at familiarizing everyone with Ground and how to use it. You'll learn how to integrate the data context from multiple sources into a single system And ground status is that it's at 0.1.2. It's a solid core system, and it's at the point in its trajectory where it's looking for more use cases. So as much feedback as we can gather for ground would be greatly appreciated. And finally, in terms of the roadmap, is exploring the layers both above and below ground. And Vikram is going to talk more about that tomorrow. So the last set of tutorials is going to be on Wave. Wave is a global scale, fully decentralized authorization system that operates with no central authority. It allows you fine-grained management of permissions across multiple IoT devices, and it allows you access and control of resources across multiple administrative domains. So the tutorial is actually really cool. As is the case with the other systems, you'll familiarize yourself with the system and its API, but you will also learn how to delegate authority to a peer sitting right next to you with no central coordination and even remotely control each other's virtual devices. Wave 2.2.0 has been released, and the key highlights of that release were full decentralization, consistent routing object views, as well as support for Ether cryptocurrency and working with smart contracts. So to recap, the focus of our inaugural RISECamp is the following. The first is reinforcement learning. It gives us the ability to make decisions and act in a dynamic environment quickly. The second is prediction serving. It enables accurate and timely decisions at scale. Third is ease of development, basically making the cloud easier to use for non-computer science domain experts. Fourth is data context service, which provides you with the ability to capture the context in which the data is being used. And finally, security enables the underlying security fabric to have decentralized authorization for a distributed set of mutually untrusting devices. Now, before I hand it over to Roy, just a few words on logistics. The Wi-Fi access point you all should be using and connecting to is CalVisitor, but we have one request for you. If you could please connect only one device per user, this will ensure that everybody has a smooth sailing experience through this tutorial session. All of our tutorials are, by their very nature, dependent on having a very good, reliable Wi-Fi service. So if you don't mind, it would be best to connect just the device that you're using for the tutorials. That would be very much appreciated indeed. And with that, I would like to introduce Roy Fox, who is going to come up and talk to you about reinforcement learning concepts. Thank you.